Hello, and today I'm going to show you this math kit. It's all about math history. It's a three-dimensional tour through mathematics by Ron Bender, Mer and Bob Gardner. Let's go into the first page. And the first page has some cards and a three-dimensional pyramid. So we have Khnum, the ram-headed god, was believed to control the start of the yearly flood. This is the card. The goddess Isis used her magic powers to protect the lives of the builders. This name is Thoth, wisest of the Egyptian gods, god of mathematics and calculation. This one is Osiris, god of the underworld and resurrection. So there are four gods: Khnum, Isis, Thoth, and Osiris. And there is a pyramid. Three-dimensional pyramid. It opens up. There is a shadow here. You can see. It has a little cutout. It says the full pyramid was 479 feet high. Note the Statue of Liberty, which is 192 feet high. So it's almost twice as high, a little more than twice as high as the Statue of Liberty. So we're on to the next page. It folds like this, and here are the numbers. Number, and this one is more likely as this is a multiplication. It's a number grid, and this one is also multiplication. It has this circle that can actually be rotated, and you can see the tables of the numbers. So 8 times 6 is 48, and 9 times 6 is 54, and 7 times 7 is 49. So it's just something to match, probably. This is also place value. So we have numbers 25, and actually you can move this piece and see the numbers change. So you got 25 times 1. You got 5 ones and 2 tens. So that's 25. Then 25 you do times 10 would be, you don't know, it's not open yet, so you're gonna use 3 boxes, which it means you have 0 ones, 10 fives, so it's 50, and 200, so 200. And the same thing with 25 times 100, so the number will be 4 boxes, which is 0 tens, 0 ones, 0 tens, 5 hundreds, which is 500, and then 2 thousands, which is 2000. So the answer is 2,500. Multiplication tables, addition and subtraction. Subtraction is always a little bit harder. Let's see, 25 cents. We have 25 cents adding to 23.75. So let's see. Just moving this little flap here. What happens? I don't know. Oh, so if you subtract, if you add in 25 cents, then I guess subtract is 12. Do we need to read this a little bit? What do you do here? The importance of place value is easily seen in addition and subtraction. Errors are often made as a result of placing numbers in the wrong column. The mechanic illustrates this is in attempting to add 25 cents. Pull the tab to correctly place the 25 cents. Lift the tab to see if you are correct. So we're lifting against this tab. So if you add in 25 cents, it's confusing because it's hard to see. Oh, I see the numbers here. $12 and this $11. So we'll just skip it because it's a little confusing. I don't know. It's my favorite is this tear off. It's supposed to tear it off, but it is more about fractions. So I'm gonna circle this like this and turn. So we got 12.5%. That's about divided by 8. The fraction will be 1 of the 8s, and decimal is 1.25. 20%, I know that's 0.2, and of course it's 1 out of 5. 1 out of 5, oh, 20 of 100. 20 by hundreds. So that's the same, going to be 1 out of 5. So 20 divided by 20, that's 1. And 100 divided by 20, that would be 5. That's the other. We got 25%, 33%, 50%, 75%, got 100%. 100% is, we all love 100%. That's 1 times 1, 100, 100, or 1. 1 we have fraction is 1.0 decimal. Let's see these classes. These are the classes. Second and first. Throughout the book, the animation glasses can be used as an alternative way to help understand mathematical concepts. Whenever you see this symbol, use the glasses in the following way. First, look through the red filter and then through the blue one. Try this one, the example below. What I see through the red lens would be 5 times 2 equals 10. That's what I see through the red one. Now I see 8 times 8 equals 10. If I look through blue lens, I see more like 2 times 5 equals 10, but with the red is very clear. But the blue is not so clear. So I'm not sure if that works completely. We'll let this out. Now we have how many 7s in 22? Okay, so that's 3 7s. 3 times 7 is 21. How many 7s are in 10? 1. 1 7. How many 7s are in 40? That's 5. 35. Reminder is the half. I remember doing this in school. Division, fraction, decimal places, and significant figures. So 3.14, 28, 57 1. To 7 decimal places, to 8 significant figures. Decimal is everything that's after the period, and significant figures are all together. If you change it to, for example, 3 decimal places, then you have 1, 2, 3, and 4 significant figures. 1, 2, 3, 4. Fractions. Fractions are easy. 2/3 plus 3/4. How much is it? Multiply by 4. 8, 12. Multiply by 3 is 2, 3, 6. 3 by 3, 9. 6 nines. Multiply by 4 is 12, 16. But also then once you get the 12 over 16, you can just divide, in this case, by 6 each number, and you will get 2 by, not that 2, divide by 2 will be 6 by 8. 6 by 8 can be also divided by 2, so that would be 3 by 4. Just multiply. Go to the next page. Got another fraction. These are the fractions. All positive and negative numbers. These are my favorite term because it's just very easy, but at the same time kind of confusing because you just going backward. Doesn't really exist, right? But it does exist in science. Counting backward and then going over the zero, so that's -1, -2, -3, -4. The funny thing is how to add those numbers and how to divide them. And what about estimation? Estimation. Let's see what is this one. This is a box. How many? I guess how many can you get into this box? You have to calculate. How many can you get in here? It's always usually an approximate number. It's not always exact because these dots, these white dots, are always random. They're not organized. These are solving equations. When I was in school, I loved the math, and I know math is not most people's favorite subject. I enjoyed that class, and I had a very good teacher for math and geometry, and we had class after class, so we had sort of after school hours when we used to meet, and we would do homework, and we would also practice on more complicated problems and try to figure them out. Just we're challenging ourselves, which I enjoyed, and I think I enjoyed it because one of the reasons because I did well. So I saw the progress, and I sort of liked to always figure out different problems, and every problem usually have an answer, either right or wrong, and I enjoy the process, just trying to solve it, trying to use different ways of getting the right answer, because that was always either the right or the wrong. And this is algebra. How this works, but we're gonna pull the first. So I guess you have these numbers that you can replace with unknown letter X, and you get the answer. And then you can put 4 or 3. If you put this, you can see that you can put different numbers 2, 2 instead of x, that would be 6. Then if you move this, I guess you have to figure out how to do 1, then it would be 5. Yes, so this is the numbers. This is the plot. I used to like to work on a plot with x and y. The dots and building those little tables. We're going to try to rotate this. See if it still works. 5 plus x equals 4. And x is minus 1. Yes, minus 1 plus 4 is minus 1 plus 5 is 4. If you want to get a number lesser than the added, then it has to be something negative. It cannot be positive. If it's a positive, you'll get a bigger number. For example, you'll get anything more than 5. Oh, 5, but not less than 5. That's why this is a negative. This is some rubber. Here, rubber. There's another rubber. No, sorry. I think this one is to show different graphics. For example, parabola. Oh, hyperbola. You pull them. Oh no, it's just to show the points on a graph. So this means plus 1, x is plus 1, and y would be y would be actually 0 because it's crossing them. It's here, so y is 0, but if you want to have y2, then you would have this rope. It would move to, if you move it like this, if you wanted to have y2, then it would be like this, yes. So that's y is 2, because it's crossing the here on the y line. X exponents 10, fourth, 10 and third, 10 and second. And this is something that you kind of have to memorize it, but it does make sense when you put it like that. Then you have the graphical solution. Actually, this can apply to here, but this is more 3D because you have X, you have Z, and you have Y. So you have 3 dimensions. We did that already. So we'll go to the next. This one is also a plot. It's different. Oh, this is the one is turning point. I don't remember the name of this graph actually. Is it the hyperbola or parabola? It's calculus. Different shapes. Stella octagonum, octahedron and cube, dodecahedron and icosahedron, icosahedron, dodecahedron, pentagram and pyramid. Square-based pyramid, triangle-based pyramid, hexagram, diamond, sphere, prism, and cube. Area, volume, area, height, and volume. That's a rectangle. And this is parallelepiped. This is trapezoid. Interesting, we can use that actually. From the red, I see more like a triangle. From the blue, I see a square. -90 minus 180. So, like that is 90. 180 would be all from here on one line. 190, this is 190. Oh, sorry, 180. This is 180. Segment, chord, sector, quadrant. Rotation. Do you all know the P, which is 3.14 15926538 It's a very long number, small. It's a Greek symbol. P is the ratio of the circumference of the circle to its diameter. In any circle, the circumference is always just over 3 times longer than the diameter, and so the length of the circumference divided by that of the diameter gives a constant value. This is known as P and is approximated to 3.14. We used the value of P when calculating the area and the circumference of circles. There's another the scale factor of an enlargement by measuring any two matching lengths. Center of the enlargement, then you have an angle. This is the mirror. Works in different ways. The reflection and translation. Handling data. Blue are apples and red are oranges. And it changes. I'm wondering about this. What do you do with this? Oh yeah, like this. That's the speed. Second car starts. Your nicked body. Mario. Vanilla, strawberry, chocolate. More pop ice cream. Problem solving. Horses. Mario ice cream. 1, 2, 3, and 4. Different varieties. These are just some number grids. Cut the cubes. Dices. This is the dices. I think at the end this is an interesting way of just showing math and what you know about it. And this probably has been created for sort of not for learning, but more for hands-on activities and making it fun. Let me know what you think of this.